Okay, good morning. Today we are going to discuss the topic memory management. Okay, so we know that when we write a program, it has to be compiled first, and you compile your program and generate what is known as the object code, and the object code is loaded into memory for execution. Right. So you get, so we have already discussed this earlier also that when we actually load the program into memory for execution, say we have a set of block of memory which is made available to us by the operating system. And how we get the memory is through the runtime environment of our language. And so we get a block of memory to load our program from the operating system. And this block of memory, we can think of it as consisting of an area where the object code is stored. Okay, we have a part where the code is stored. Then we have another part where we have the global variables and static variables stored. Okay, some part which is allocated at the time of compilation itself, which is the set of global variables, static variables, etc. So that is one other part. Then we have another part called stack. So we have already seen where the application of stack. When we were discussing stack, we saw that the stack is the area where the local variables are stored when a subroutine is being called. Right, the return address as well as local variables are stored in the stack. And there is another part of this program which is called a heap, which is the area from which memory is allocated, dynamically allocated. That is when you make a call to malloc, let us say. The data is actually allocated from a part of this memory called a heap. Right. So what we are talking about here is how is this memory being managed? Okay, how is this memory being managed? And memory management actually in C++ is the responsibility of the programmer in the sense we use malloc function to allocate memory from the heap, and we also use free. Free is another function or system call which is used to return memory back to this heap. Okay, so it is explicitly taken care of by the programmer, but in other languages, let us say Java or Python, that is automatically taken care of by the language itself. There is no function like malloc or free. Okay, so that is why memory management here, what we are talking about is how blocks of memory are allocated from this heap area during dynamic memory allocation and how it is being restored back. Okay, so heap is a region of main memory from which portions of memory are dynamically allocated upon the request of a program. Okay, so okay, dynamic storage. You can think of a program consisting of static storage as well as dynamic storage. Static storage means the amount of memory required for running that program is actually allocated to you during compilation time. And say we know that it's fixed. We do not use sub memory during runtime. Okay. And for dynamic memory allocation and management, a linked list is used for implementing dynamic memory allocation. Okay, so you see here we are talking about this is an application of linked list. Okay, so we can think of this heap area which we said is consisting of that is we have an avail pointer. Avail is a pointer to the list of available blocks within the heap. Okay, so initially the heap is actually a single block of memory and there is a single pointer to it, say for example like this. Okay, so avail is a pointer to a block of memory which is available in the heap, and it is from this block of memory that we are going to allocate pieces of code as and when we request. Say, for example, when we want to create a node in a linked list, or when we want to create a node in a tree. So we call malloc as a function, and we want to get certain size, say 100 blocks, or the size of a struct, right? That is what we generally do. So we want to get certain amount of memory. So from this block of memory we get this particular, that is whatever we need is allocated from this block, and the remaining will be available as a linked list. Okay, so that is the general idea or general picture of um, how memory is being maintained. Now, for allocating memory, actually, there are two strategies. One is fixed block allocation and another is variable block allocation. So, fixed block allocation means we are assuming that the memory itself, the heap area is actually divided into blocks of fixed size. Say, for example, this. Okay, you have a avail pointer pointing to a linked list consisting of multiple blocks of all of them are fixed size, say 100 bytes. That is, so we are making a request, and uh, what happens is when we want to create, say, a node in a tree, we are making a request through malloc function, and we'll be allocated a pointer to one block of memory here, and now the avail pointer will no longer point because this is no longer available, it has been allocated to our program. So it the avail pointer will actually point here. So next request comes, you will have similarly the next one allocated and so on. Okay, so the size of memory which needs to be, the fixed block size has to be decided by the system depending on what sort of request will come for come to it. Okay, so but this is not really feasible because mm, always when you have fixed block size, maybe let us say for example fixed block size is say 100 bytes, and we are only requesting for 10 bytes, but we are being allocated this whole memory, which means the remaining 90 bytes within this block is not utilized. Okay, it's called internal fragmentation, which we will look at later. But that unutilized memory is actually a limited resource or a very valuable resource, and that is not being utilized. So fixed block is only theoretically, we can say the fixed block you have a sort of memory allocation, but it is not feasible. So we move on to another allocation scheme, which is variable block allocation. So variable block allocation, as the name itself implies, you have a linked list, or the avail list consists of multiple blocks which are of variable sizes. And the request which comes to our system will also generally be of varying sizes, and depending upon which memory block is allocated. That is, you have many strategies within the variable block allocation itself, and based on these, the memory will be allocated. So we have first fit, next fit, best fit, and worst fit. So the first fit memory allocation means, so we said we are talking about a variable block allocation, that is we have got a linked list of memory blocks of varying sizes. Okay, so first fit means you traverse the linked list and you allocate the first block which is suitable for you. Say you are requesting for 100 bytes, and the one which is closest to it for other which you encounter first, that is what first fit means, which is the block which you encounter first and which is suitable to you. So that is first fit strategy. Next fit means, uh, so we said we have an avail list, right? So always the avail pointer points to first and നമ്മൾ assume ചെയ്യുന്നത്. When in the case of next fit means, uh, your avail pointer will not always point here. It will point maybe to the next one. Okay, നമ്മൾ ഇവിടുന്നാണ് allocate ചെയ്തതെങ്കിൽ say 100 bytes ഇവിടെ request ചെയ്തു, let us say 100 bytes request ചെയ്തു, and let us say this is 200 bytes ആണെങ്കിൽ, then 100 bytes is allocated. Okay, and the remaining will be retained here. Okay, so if you have a 200 byte storage, and the system asks for 100 bytes, 100 bytes of this is allocated from this node, the remaining 100 bytes will be retained. Okay, and your avail pointer was here. Now in the case of next fit, you don't start from here the next time, you start from the next node. So why we do this is because if you start from here again, this first node has only 100 bytes left, and if your next request is for 10 bytes, again you'll have a 90 bytes left here. So which means beginning of the list you have smaller and smaller fragments remaining. So in order to avoid that, what is done is once you allocate from this point, ഇനി നമ്മളുടെ next avail point moves on to the next point, so that next allocation starts from the next node. And once say this is also 200 bytes, let us say, and you have 10 bytes allocated, which means you have 190 bytes left. Okay, next our avail pointer points to the next node, and so on. So that beginning first fit it always starts from the avail pointer at the beginning, which means നമ്മൾ ഒരു ബ്ലോക്ക് ഓഫ് മെമ്മറി അലക്കേറ്റ് ചെയ്തിട്ട് റിമൈനിങ് ബ്ലോക്സ് നമ്മളവിടെ മെയിൻറ്റെയിൻ ചെയ്യുന്നുണ്ട്. ആ റിമൈനിങ് ബ്ലോക്ക് കുറച്ചുകൂടെ ചെറുതായിരിക്കും. അപ്പോൾ if you use the first fit strategy, always you have smaller and smaller blocks at the beginning. To avoid that, we using the next fit strategy. And best fit. Okay, best fit means always you start from the beginning, you traverse through the whole linked list, and you find out which block is closest to it. എന്ന് പറഞ്ഞാൽ നമ്മൾ ഒരു ബ്ലോക്ക് 100 ആണ് റിക്വസ്റ്റ് ചെയ്യുന്നത്, and you compare that quantity with every block available in the avail list. എന്നിട്ട് അതിൽ നമ്മൾ ഈ 100 എടുത്തു കഴിഞ്ഞാൽ റിമൈനിങ് ഏറ്റവും ചെറുത്, അതായത് ബെസ്റ്റ് ആയിട്ട് ഫിറ്റ് ചെയ്യുന്ന ഏത് ബ്ലോക്ക് ആണോ ദാറ്റ് ഈസ് ബീങ് അലക്കേറ്റഡ് ടു us. Okay, that is best fit strategy. Now the problem with best fit is it will result in very small blocks. കാരണം ഏറ്റവും ബെസ്റ്റ് ആയിട്ട് ഫിറ്റ് ചെയ്യുന്ന റിമൈനിങ് ആയിട്ട് വരുന്ന സംഭവം വളരെ ചെറിയ ബ്ലോക്ക് ആയിരിക്കും. Okay, so in order to avoid that sort, you have another strategy called a worst fit. Worst fit ചെയ്യുന്നത് best fit പോലെ തന്നെ it will traverse the whole list. Okay, and it will find the block which is the worst fit or the biggest one, that is which will what which will leave back the a block which is the largest. Okay, we look at the examples, but first fit means you find out the first block which satisfies our request for quantity. 100 bytes ആണ് റിക്വസ്റ്റ് ചെയ്യുന്നെങ്കിൽ 100-നേക്കാളും കൂടുതലുള്ള ഫസ്റ്റ് നമ്മൾ ഏത് കാണുന്നു അതിനെ നമ്മൾ എടുക്കുന്നു. നെക്സ്റ്റ് ഫിറ്റ് എന്ന് പറയുമ്പോൾ you are actually moving the pointer to the next node. Next time you search, you don't start from the beginning, you start from the next pointer after the one which you allocated already. Best fit means you're searching for a block uh, which leaves behind the smallest remaining block. Worst fit means you're looking for the largest block in the set, so that whatever block which is left behind is the largest, so it does not result in very small fragmented blocks. Okay, so this is the strategy. Okay, so we look at this example. Okay, so we are assuming initially we have one contiguous block of memory with us. Heap എന്ന് പറഞ്ഞു നമ്മൾ beginning always it will be one contiguous block. Then after that maybe you will request many blocks from it, and it is after many requests and returns that you will have a set of smaller blocks. Okay, so initially we have 4k and I'm making a request of 1k. So 1k is allocated to now the program, and the remaining 3k is retained. So again you have only avail list only contains one block of 3k size. Now suppose if 1k is returned back, then you have two blocks now, 1k and 3k and so on. So generally after many requests and returns, you will have multiple blocks like this. Okay, so we look at one or two allocations and see how each of these strategies of first fit, best fit, next fit, and worst fit works. Okay, so this is where we start initially. Okay, so this is the avail list we are starting with, and let us say I am starting. I want a block of say 235 bytes. Okay, അപ്പോൾ first fit strategy ആണെങ്കിൽ you will traverse this block and find the one which fits. First ആയിട്ട് നമുക്ക് fit ചെയ്യുന്ന block is 300. 200 won't fit because you need 235 bytes. So this is the block which contains a memory for us, right? Which contains 235 bytes. So 235 bytes will be allocated from it, and here the remaining bytes will be left in the list. So remaining 65, this block now will contain 65 bytes remaining in the avail list. 235 bytes will be allocated to our program. Okay. Um, Now that is in the case of first fit. Best fit ILM, it will still traverse the whole thing and it will allocate this itself, because this is the one which will it is suitable for us, as well as which will leave out the least amount of remaining space. Okay. If a worst fit ആയിരുന്നെങ്കിൽ we would go for this particular block, because that is the one which will leave out the biggest remaining block. Okay. Now let us say, so I have allocated 235. Now 235 has been allocated. Now let us assume I want, say, some 25 bytes. Okay, I want just 25 bytes. Okay, first bit strategy ആവുമ്പോൾ എന്ത് ചെയ്യുന്നു, you will start from here and you will find 100 bytes here. So it will give you 25 bytes, and the remaining 75 bytes will be left here. Okay, so this block will contain 75 bytes and 25 bytes will be allocated. That is for first bit. Best fit ആണെങ്കിൽ എന്ത് ചെയ്യും? Best fit will actually traverse the whole list and it will find 65, which is the best fit for 25, and it will take 25 and the remaining 40 will be left here. Okay, so this is how it works. That's the difference between first fit and best fit. Worst fit ആയിരുന്നെങ്കിൽ, again, even if you are asking for just 25 or 10 bytes, you still get 500. Now, what about next fit? That is the other thing we have to discuss. So earlier, for the first allocation, when I asked for 235 bytes, it is from this block that we had allocated space requested, right? If we are following next fit, now we don't start the search from the beginning. We start the search from here in a circular manner. Okay. So next fit means you will actually allocate space from here. Okay. So that is the different strategies for memory allocation: first fit, next fit, best fit, and worst fit.